Hi everyone. So this video is part 5 and the last video of statistics. Let's see the agenda of today's lecture. The learning objectives of this lecture are to learn about what is covariance, what is correlation, and we will also see how we can convert covariance into correlation in our programming language. Now let's move forward. In statistics, the terms covariance and correlation are used to describe relationships between two random variables. The linear dependence between two random variables or bivariate data is measured by both of these terms. The functions in R which make use of the covariance and correlation methods of statistics and probability theory will be covered in this lecture. In the discipline of data science and analytics, determining the strength of the association between the variables in a dataset is really important. Covariance and correlation will be the instruments we examine in this regard. So, what is actually covariance? The measure of the relationship between two variables in a dataset is called covariance in statistics. For example, when two variables have a strong positive correlation, they advance in the same direction. In the fields of data science and machine learning, covariance is helpful in the pre-processing of the data before modeling. The covariance function in our programming can be used to calculate covariance. The statistical concept of covariance is utilized to quantify the linear relationship between the data vectors. It's a way to quantify the relationship between several variables. When such correlation matrix examines how variables differ from one another. The syntax for finding the covariance is quite simple and as follows. You just use the covariance keyword and then pass the data vectors and the method. There are several methods such as Spearman, Kendall, and Pearson, where the sort of procedure to be used to determine covariance is defined by the data vectors x and y. Pearson method is used by default. Now let's move to our studio to see how this function actually works. Well, first of all, I will set my working directory. I say data science D, data science R. All right. So first of all, I will say msleep and I will say read.csv. And here I will read my CSV file, which is msleep.csv. And I say head msleep. All right. So you can see the head of your dataset right here. Now, for instance, I want to calculate the covariance between body weight and brain weight. I will say covariance. By using this keyword, I will pass the data frame and then the variable or column, which is body weight. And on y-axis, I pass the data frame of msleep and the variable or column of brain weight. All right, let's use a parameter of use because I know that this column contains some missing values. So by using use equals to complete, you just drop the missing values. Let's see the covariance. All right, so it's 862.39. Now, this is a positive covariance. So it means that the relation between body weight and brain weight is positive. It means that when body weight increase, brain weight also increase. If you want to say it, then you can also visualize by saying msleep, body weight, msleep, and brain weight. All right. Now you can see here that as the body weight increase, brain weight also increase. You can also change the method of finding the covariance. And this time, let's say I want to calculate the covariance with the method of Spearman. All right. So you can see here that the covariance is changed this time because we changed the parameter. There is one more parameter, which is Kindle. Let's use it. Well, we know that this is a basic course, so that's why I will not go into that much details. So according to the Kindle, the covariance is 2578. Kindle is used for big data sets that contains the values or observations more than 1000. Now, let's move back to slides. Next, we have correlation. The statistical approach of determining the relationship between the variables in terms of the movement of the data is called correlation. Two variables are said to depict the same information and have the same influence on the other data variables in the dataset when they have a high degree of positive correlation. Our programming's correlation calculates the correlation coefficient value. The correlation method or function is used to assess the strength of the relationship between the vectors in the statistical concept of correlation. The syntax is as follows. Just use the correlation keyword and pass the parameters, where this kind of procedure to be used to compute correlation is defined by the data vectors x and y. Let's see in RStudio that how it works. For instance, I want to see the correlation between the mSleep data frame variable of body weight and the variable of mSleep and mSleep's variable of brain weight. And I say use equals to complete to drop the missing values. Let's run it. So you can see here that the correlation value is 0.9. Now correlation function bounds the value between -1 and 1. If the value is 0, it means that there is no correlation between two variables. If the value is close to 1, it means there is a high positive correlation between variables. If the value is close to -1, then it means there is a high negative correlation between the variables, which means that if a variable is decreased, the other variable will increase. So that is how the correlation function works. For instance, I want to see the correlation between the mSleep data frame variable of body weight and the variable of mSleep data frame awake. And here I use the parameter of use equals to complete. Let's run it. So you can see that the answer is 0.3. So it means that there is no such a good correlation between these two variables. You can also use method in the correlation function as well. Now let's move back to slides. Next, we have conversion of covariance to correlation. In our programming, the curve to curve function transforms a covariance matrix into a corresponding correlation matrix. It transforms the covariance matrix into a values-based correlation matrix in simple. The syntax is as follows. You just use the covariance to core keyword and pass the data vector, where the square matrix of covariance is represented by x and y. Now let's move to our studio to see how this one works. Now, first of all, I will create a matrix of vector. I will say matrix, and here I will use the combine function. I say that vec 1 contains values such as 1, 2, 3, 4, and 5. And similarly, I have vec 2 that is also a matrix, and it contains the values such as 2, 4, 6, 8, and 10. Now, first of all, I will say co1, and inside this variable, I use the function of co to find the covariance between these two matrices, vec 1 and vec 2. All right, and here I say print co1, and then I say result, and inside this variable, I use the function of covariance to correlation, and I pass co1, and here I say print, and then I pass the variable of result. So first of all, I have found the covariance, and then I have converted the covariance into correlation by using this function. Let's run it. All right, so you can see here that the covariance was 5 and the correlation is 1 because the relation between these two matrices was positive. So that is how you can use these functions. Now let's get back to slides. So today you have learned about covariance, correlation, and how you can convert covariance into correlation. I have got some homework for you. You have to find the covariance and the correlation, and also do the conversion of covariance to correlation. And here I have placed the link of the dataset, which you can access by one click. So this is the end of this outline. Now good luck. See you next time.